So hello and welcome everyone. So in this video, we are going to solve the question minimize the heights 2. This is the problem of the day and the question is very much interesting. The logic behind solving this question is also very much interesting. So let's keep the target of 50 likes in this video and without any delay, let's start the video. So first of all, let's try to read down the problem statement. So in the question, you will be given an array denoting heights of n towers and a positive integer k. There will be n towers and there will be positive integer k. So for each tower, you must perform exactly one of the following operations exactly once. So you can increase the height of the tower by k or you can decrease the height of the tower by k. For each and every value in the array, you can either increase it by k or you can decrease it by k. And each and every operation can be applied only once, either of the two one. So now what you have to do, you have to find out the minimum possible difference between the height of the shortest and tallest tower after you have modified each tower. After applying operation on each tower, you have to find out what is the minimum possible difference between the height of the shortest and the largest tower. One note has been mentioned over here that it is compulsory to increase or decrease the height by k for each tower. You have to compulsory apply the operation, and after the operation, the resultant array should not contain any of the negative integers. Okay, so after the operation, the resultant array should not contain any of the negative integers. So now let's try to understand with the help of the test case given over here. So let me just copy this test case and let's try to solve the test case. Okay, so over here the value of k given to you is equivalent to 2 and n is equivalent to 4. And the array elements are 1, 5, 8 and 10. Now either I can increase the value by 2 or I can decrease the value by 2. So these are the two operations from which I can apply. I can either apply this or this operation. So now what I have to do, this is the entire array. So first of all, before applying the operation, let's try to find out the difference between the smallest and the largest element. So the smallest is 1 and the largest one is 10. So 1 and 10, on what is the difference? So 10 minus 1 will be equivalent to 9. Now what I will be doing one by one, I will be either applying plus 2 or minus 2 on each and every array element. So let's start with the first element. What if I apply minus 2 on 1? So it will be a negative value, right? So I cannot apply minus 2, I need to do plus 2 for this one. So it will be equivalent to 3, right? So I have done plus 2 on this one and I can see the value becomes 3. For now this 5, what I will be doing, I will be trying to decrease the value by 2. So 5 minus 2 will be equivalent to 3. Now for this 8, again I will be trying to decrease the value by 2. 8 minus 2 will be equivalent to 6. And for this 10, what I can do, I can increase the value or decrease the value. See, the target is to minimize the smallest and largest, the difference between the smallest and largest element, right? Now for this 10, if I increase the value by 2, so 10 plus 2 will be equivalent to what? It is equivalent to 12. So the largest element over here will be 12, but I don't want this. I want to minimize the difference between the smallest and the largest one. So instead of applying plus 2, I will be doing minus 2 for 10. So 10 minus 2 will be equivalent to 8. So now over here in this modified array where I have applied each operation at least once, so what is the smallest one? 3. And what is the largest one? It is equivalent to 8. So 8 minus 3 will be equivalent to 5, and this is the smallest possible difference between the smallest and the largest element, the minimum difference possible. So if you try out different other combination of doing plus 2 or minus 2, you will not be able to minimize this value. And now what will be the output of this test case? The output of this test case comes out to be 5. And you can check inside the output of the example number 1, the output is also equivalent to 5, right? So this is the entire question, and in this manner you have to choose either plus k or minus k for each and every array element. And if you do so, you will be getting a modified array, and you have to find out the difference between the smallest and the largest element. So this is how the entire question works. I hope you understood everything about the question. So now let's try to brainstorm and let's try to understand how to solve this question. What can be the algorithm of solving this question? So now, before starting and before understanding the optimal approach, what I'll be doing, I'll be going through the brute force approach. What can be the brute force approach? So in the brute force approach, you might have already guessed, you can apply both the combination. You can try out plus k and minus k for each and every array element. We know how many array elements are going to be there. There are n array elements, right? And for each and every array element, I have two operations. I can do either plus k or minus k. So now what will be the time complexity if you try out each and every other combination? So the time complexity will be around 2 to the power n. It will be exponential, right? So the brute force approach, if you have thought of doing the brute force approach, it will be not feasible. It will not be accepted because it is going to take much amount of time. So now we strictly need to be on the safer side, and we need a different approach, which will be far better than this exponential approach. So now for this approach, what I need to do, see, first of all, as I mentioned, for each and every element, you have two options available. You can either do plus k or you can do minus k, right? You can either do plus k or minus k. So there are two different possibilities. So now over here, if you try out each and every possibility, this is not going to work. You need to act little bit smartly so that you can easily solve this question. So let me explain you what can be done. So over here, let's say this is the entire array, and this is the array in which I have already sorted this entire array. Okay, so now let's say after sorting the array, this is the entire array. So A is the smallest element and B is the largest element, and there are different elements between A and B. So now on the number line, if you try to observe A and B on the number line, so here will be your A and here will be your B, and all the other elements will be lying between this range A and B, right? So now if I want to decrease the value, if I want to minimize the difference between A and B, before applying the operation, the difference will be B minus A. Do you guys agree? Before applying the operation plus k or minus k on every array element, the difference is going to be B minus A. Now, if I want to minimize this entire difference, what I can do, I can somehow bring the value of this A on the right hand side, and I can somehow bring the value of this B on the left hand side. So if I want to bring the value of this B, if I narrow down this entire range to something like this, earlier it was this range. Now if I narrow down this range into this much, so if I apply plus k, to this A, and if I apply minus k to this B, I can narrow down this range. Do you guys agree? So if I do plus k, if I do A plus k, and if I do B minus k, the difference between the largest and the smallest one will be reduced now. If you want to check the difference, so B minus k minus A plus k, what will be the value? So that would be B minus k minus A minus k, and that comes out to be B minus A minus 2k, right? So this is the value, and obviously earlier what was the value? Earlier the difference was B minus A, and now what is the difference? After narrow down the entire range, the difference is B minus A and minus 2k. I'm subtracting something extra from this the range. So obviously the difference has been reduced down. So now what I will be doing? So I will be keeping the smallest value. I'll be having two different variables. The smallest one will be what? It will be nothing but it will be B minus A. So basically the smallest value will be what? It will be A plus k. And the largest value, what will be the largest value? So the largest value in this scenario will be B minus k, right? So for the first element and for the last element, I have made sure that this is the most feasible option which I can do. I can either increase the value of A for the smallest one, and I can decrease the value of the largest element by k. So I have got two different values for the first element in the sorted array, and for the last element in the sorted array. I have figured out that this is the thing which I can do. I'm not sure whether this is correct thing or wrong thing, because it is possible that if I'm going to modify the elements present in this range, if I'm going to modify the other values, then it might appear the smallest might change to something else. The smallest might change to something else, and the largest might change to something else. It is possible, right? So now this is the first thing. So the first thing what we are going to do, the first thing is that we are going to sort the array. So on sorting, I will be getting a range. A to B will be my range. And now after that, I came to know that I have the smallest and the largest element. And what I did for the smallest and the largest element inside the sorted array, I was able to figure out that what will be the smallest value. So the smallest value will be A plus k after applying the operation, and the largest value will be what? It will be B minus k after applying the operation. For A and B, I have figured out what I can do. Now, what can be done further? So the further thing is that for these two values, I have identified, okay, so this can be the thing. Okay, so now over here, there will be one answer variable available, right? See, I need a variable that will store my final answer. So what should I initialize this answer variable? Let's try to think for a few minutes. Let's take one example. Let's say all the array elements are 1 in this case. Okay, and let's say This is the entire array. The value of n is equivalent to 4 and the k value given to you is equivalent to 3. Now, on this entire array, can you apply -3? Can you decrease the value of each and every array element by 3? Is it possible? Do you think it is possible? Obviously not. If I apply -3, then all the array elements are going to be negative. And according to the quotient, I cannot have any negative values inside the array. Fine. So what will be my option? What I can do? So if before applying the operation, before applying -3 or +3, what is the difference between the largest and the smallest one? So that difference is answer is equivalent to 1 minus 1, and that answer, temporary answer, is equivalent to 0. Right? So now over here, what I can do? I can simply apply +3 on each and every array element. I can apply +3 on each and every array element. So the array will become 4, 4 and 4. So now what is the difference between the largest and the smallest one? So the difference between the largest and the smallest one is 4 minus 4 is equivalent to 0. I cannot see any change in the answer. Earlier also, before applying the operation, it was 0, and after applying the operation also, it is equivalent to 0. So there might be some of the test cases in which the answer remains unchanged. So what I will be doing, whichever answer variable I will be having to store my answer, I will have that answer variable initialized to the difference of the largest and the smallest element. That will be initialized to difference of the largest and the smallest element. Okay, and over here A is the smallest one and B is the largest one. A is the what? Smallest element, and B is what? It is the largest element. Okay, so do not confuse yourself. So this is A and this is B. Basically, you can do largest minus smallest element. It is largest minus smallest. So I will initialize my answer variable with what? Largest minus smallest. And this is the proof that I can initialize it in this manner. Right? So now we have understood, okay, so these are the things. And for two elements, I was able to predict, after sorting the array, I was able to predict for the smallest one and for the largest one, that for the smallest one, what I can do, I can increase the value by k, and for the largest one, I can decrease the value by k. This is the entire prediction for these two elements. Now, what can be done for the rest of the array elements? Now, what can be done for this many elements? So now here comes an intuition. Here comes very interesting part. Let me take one more example. Let's say it is 1, 3, 5 and 7. Okay, and now for this array, let's say n is equivalent to 4 and k is equivalent to what? K is equivalent to, let's say, 4. Okay, so now over here, for this element, for this entire array, what I will be doing, first of all, let's say to initialize the answer variable. What can be the answer over here? 7 minus 1 will be equivalent to 6. So this is my initialization of the answer, right? This is the answer. That is basically the difference between the smallest and largest before applying any of the operation. Fine. So now for n is equal to 4 and k is equal to 4. So now if I apply the operation for this element, can I do plus k? Basically, can I do minus k for the first element? Can I do 1 minus 4? No, I cannot do 1 minus 4. So what can I do? I can simply do plus 4. Similarly, for this 3, can I do minus 4? So 3 minus 4 is equivalent to minus 1. I cannot do minus 4 for this element as well. I can simply increase the value. But after this point, for this 5, can I do plus 4? Obviously, you can do plus 4. And can I do minus 4? Obviously, you can apply plus 4 and minus 4, both of them. Both of them are possible, right? So now over here in this scenario, there is a pivot point. There is a pivot point that before the pivot point, all the elements can only have plus k operation on it. Right? Over here, this was the pivot point. That before, in this range 0 to I, all the elements can only handle plus k as an operation. It cannot handle minus k as an operation. So now over here, what I will be doing, I will be iterating over the pivot point. One by one, I will be checking whether, let's say if this is my pivot point, then what will be my minimum and what will be my maximum element. Okay. So how will I find what will be my minimum and what will be my maximum element? So whenever I say this is my location of the pivot point, you have to understood that all the elements in 0 to I have been applied plus k operation, and all the elements from I plus 1 to n minus 1 have been applied what? Have been applied minus k operation. Because it is possible that some of the elements cannot handle minus k in the range 0 to -1, in 0 to I, right? So this is what I'll be doing, that I'll be iterating over each and every array element from 0 to n minus 2, that is the last element, 0 to n minus 1, basically 0 to n minus 2, that is the last element, and I'll be finding that what will be my minimum and maximum element in that scenario. So how to find the minimum and maximum element? So this is the entire sorted array, right? So every element will be in increasing order in this manner, right? So this will be the entire building height. Let me draw it in a clear manner. So let's say this is the element, this is the element, this is the element, and this is the element, and this is the element, right? So now initially, what is the smallest element? Smallest one is this one, the smallest one. And what is the largest element? This is the largest element, right? Now I have to apply the operation. And now let's say for this was my pivot point, this is my pivot point. So in 0 to I, what I can do, I can only do plus k. So the range, so the value of the buildings, basically the height of the building might have been increased to this, and this might have been increased to this much, right? So now in this scenario, it is possible that your smallest and the largest element might have changed. So what can be the smallest and the largest element? That is, what can be your minimum element and what can be your maximum element? So initially your smallest is this one. Smallest is the first element and the largest one is this element, right? So basically your smallest will be what? It will be array of 0 plus k, and your largest element will be what? Array of n minus 1 minus k, right? As I explained that these are the two predictions which I can do on the first and the largest element, smallest and the largest element, right? So now how to find the minimum and maximum after applying? Let's say if this is my pivot point, there will be changes in the minimum and the maximum element. So minimum will be what? It will be what? It will be minimum of the smallest element and array of I plus 1 minus k. So what I did over here, see, I said that this is my pivot point, my I is over here, right? So all the elements from 0 to I minus 1, I have assumed that I have done plus k to them. I have applied plus k operation. So all the elements in this range can be done minus k. I have applied minus k operation on all of them, right? So now what will be changes in my smallest and the largest element? So it is possible if I do plus k over here on each and every array element, if I do minus k on each and every array element from I plus 1 to n minus 1. So let's say this will be reduced to this much, and this will be reduced to this much, this will be reduced to this much, and this will be reduced to something this much. So this much part will be deleted from every array element in the range I plus 1 to n minus 1, if this is the scenario, right? So this will be the reduction done. So now what will be your maximum and minimum value? What will be your maximum and minimum value? So your maximum in this range, what will be your maximum value? Your maximum value will be the last element. It will be array of, your maximum value will be array of this element. Basically your maximum value will be the last element. What will be the smallest one? So the smallest one will be what? It will be array of I plus 1 minus k. So I have reduced minus k from the I plus 1th element, and in this range, in this part, in this much of part, the smallest element will be array of I plus 1 minus k. I am comparing this value with the smallest which I have predicted, that is this one. Similarly, in the same manner, I have to find out the maximum value. So these are the initial values, right? This is the entire sorted array. Okay. Now let's say this is your pivot point, and in the pivot point, here is your I, and all the elements from 0 to I minus 1, what are they applied? They have been applied plus k operation, and all the elements in I plus 1 to n minus 1 have been applied what? I have been applied minus k. So assume that I have applied minus k on all of them. So the value of every array element from I plus 1 to n minus 1 will be this much, right? So these are the new values after applying the operations, right? And over here, after applying plus k operation, the new value will be this much, right? So these are the new values. So now I have to find out what can be the maximum value. So I have explained what is this mi, what is the minimum value, that is minimum of smallest and array of I plus 1 minus k. Now what will be maximum? Maximum, let me help you to understand what can be the maximum. Now I want the answer from you guys. Try to think what can be the maximum. See, initially this is my smallest and this is my largest. And we know smallest is what? It is basically array of 0 plus k. And what is the largest one? Largest is the array of n minus 1 minus k. As I explained that the range will be reduced down. I have predicted the plus k or minus k for the smallest and largest element, right? So now over here, I have to find out what can be the maximum. If my maximum might have been updated, it is possible that your largest element remains this largest element, right? It is possible that this largest element remains as it is. So one of the candidate will be what? One of the candidate will be largest variable itself. It will be largest variable itself. And over here, in this range, which is the largest element? In this range, the largest element is this one. It is what? It is array of I plus k. So basically, I have reduced minus k from this element. The element standing at the pivot point. So maximum will be updated to array of I plus k. So maximum of these two values will be your updated maximum value after applying the operation. So this will be the updated maximum and minimum at each and every pivot point. And now you can update the value of the answer variable to what? Answer variable will be nothing but answer variable will be minimum of answer and updated maximum minus minimum. So this is how we can find the answer. But now one more thing we need to handle. See, as I mentioned, as I'm doing minus k, it is possible that the value of this mi, this value of array of I plus 1 minus k might have been reduced down to negative. So in order to handle that, the value of mi is negative. If the value of mi is negative, then I will not apply this formula. I will simply continue. I will not apply this formula because if mi is negative, let's say mi was equivalent to 10 and mi is equivalent to minus 9. So 10 minus minus 9 will be 19. It will not be a smaller value. And obviously, according to the question, that thing negative element is not accepted in the operation, right? So this is the entire algorithm. This is the entire thing what we will be doing. And now let me try to summarize the entire algorithm. I hope you understood it. This was a little bit complex, the understanding part, but let me just quickly write down the entire algorithm. Okay, so this is the entire algorithm. So the first step is to sort the entire array. So after sorting the array, what I need to do? I need to find the answer variable. So what will be the answer variable? As I mentioned, for some of the test case, you might be applying only plus k operation. If you apply plus k on each and every array element, the difference between the largest and smallest before applying the operation and after applying the operation is not going to change. So that would be array of n minus 1 minus array of 0. And now I need the smallest and the largest element. What will be my smallest element? Smallest element I have predicted for the 0th element, for the array of 0th element. I know one operation what I can do. I can just do plus k, right? So reducing down the range of the elements. So array of 0 plus k will be the operation. That will be my smallest element, and largest element possible is array of n minus 1 minus k. So this is the smallest and largest element. Now I need to work on the pivot element. So on the pivot element, I am assuming that all the elements from 0 to the pivot element, basically from 0 till I, for all these elements, what I will be doing, I will be simply increasing their values. And for all the elements from I plus 1 to n minus 1, I will be simply reducing down their values by minus k, right? So I will be having a for loop that will be starting from I is equal to 0 to I is lesser than n minus 1. I am not iterating till the last element. You will come to know why I am not iterating, because according to this formula, that is, now your mi might have been updated, the minimum value element and the maximum element might have been updated. So minimum will be what? Minimum will be nothing but minimum of the smallest element which you have predicted and array of I plus 1 minus k. And what will be the maximum value? So maximum will be maximum of largest element and array of I plus k. In this range, in 0 to I, if I applied plus k on every element, what will be the largest element? So the largest element will be array of I plus k. So I have compared it with the largest which I have predicted, And in this range, in I plus 1 to n minus 1, if I applied minus k on every element, then what will be the smallest element? What will be the smallest element? It will be what? Array of I plus 1 on which I have done minus k. This element will be the smallest one because the entire array is sorted. So this is the reason why you need to sort the entire array. So let me just put this little bit far away from the algorithm, so the algorithm looks prettier. It would be cleaner. Array of I plus k. Fine. And this entire logic is for what? It is for the pivot element. Okay, so let me copy this over here. Now what I need to do, I need to check if I have done negative element, if I have handled negative element or not. So if mi, that minimum element, is lesser than 0, I will not apply the formula. I will just continue from here itself. And if this is not the scenario, answer will be what? Answer will be minimum of the answer which I have already found and the difference between the maximum and minimum value, right? And the fifth step is to simply print or return the answer variable. Fine. So this is the entire algorithm. This is the entire algorithm, and I hope you have understood the entire algorithm. Okay. So what will be time and space complexity of this algorithm? So the time complexity will be sorting, that is order of n log n plus order of n, but I am ignoring the order of n. So the overall time complexity will be order of n log n. What will be the space complexity? Space complexity comes out to be constant. So this is your time complexity and this is your space complexity. Okay. So try to take one more test case and try to understand how this entire thing is going on. I have shown you different test cases, that why we need to do this and this step, right? So now let's move and let's try to understand what is the implementation part. So over here I have implemented the entire algorithm in Java, but the same can be implemented. Take the reference of the algorithm and you can implement it in whatever language you want. Okay, so here is the first step of the algorithm, that is sort the entire array. So answer variable will be what? Initialized to array of n minus 1 minus array of 0, that is largest minus smallest difference. And now I have two different values, that is smallest and largest. I have predicted for the first element it will be plus k. I am applying array of 0 plus k. And for the largest element, it is possible that the last element remains largest. So I have done minus k on that element. And now these are the local variables mi and ma, that is minimum and maximum based on the pivot element. So now for the pivot element, I have iterated from 0 till n minus 1, that is till the second last element. Okay, so mi, that is minimum, current minimum. What will be the current minimum? It will be nothing but the minimum of the smallest which you have predicted and array of I plus 1 minus k, that is I plus 1 to n minus 1. In that range, what will be the smallest element? It will be array of I plus 1 minus k. And what will be the maximum element? Maximum will be the largest which I have predicted, and in the range 0 till I, the largest one will be array of I plus k. So after doing that, I have handled the case in which the negative elements might be possible. So if negative element is possible, then I am just continuing. I will not update the answer variable. And now if it is not the scenario, then answer will be updated to what? Answer will be updated to math.min, basically minimum of answer and difference between current maximum and current minimum based on your pivot point. And at the end, you have to simply return the answer variable, and that's it. So now let's try to submit this entire solution and let's have a look at the acceptance. And we can see that the problem has been successfully submitted. So that was it for in this video. I hope you understood everything about the solution. And this question was kind of trickier, but we need to keep in mind different algorithms. Basically, we need to keep in mind different test cases to understand. And I have shown you the example of every test case, why we need to do this and that thing. So that was it for in this video. Thank you for watching. I'll see you in the next video. Bye bye.